These are notes 7.1, direct variation. So direct variation is a function in the form of y equals k times x, where k cannot be equal to 0. K is called the constant of variation. It's the coefficient of x, and we're going to think of it just like the slope, okay? It's what we find in front of our x value, or x. An equation is a direct variation if the graph is a line that passes through the origin, and the equation can be written in the form of y equals k times x. It is another way to describe a proportional relationship where y varies directly with x. Okay, direct variation, so it's going to vary directly. Looking at the first example. So it says write the equation for each example and determine if the relationship is a direct variation. So remember, we want to be able to write our equation so that it's y equals k times x. There should not be plus or anything because it's going to go through the origin. So I'm going to start with typing this into stat edit. So I'm going to type in 1, 3, and 5 and go type in my y values of 6, 18, and 30. They're typed in, so I'm hitting stat, going over to calc, number 4. And I see that my y-intercept is 0. So my a, which is my slope, is 6 and my y-intercept is 0. So that means my k is 6. So my equation is y equals 6x, and remember, we don't need to put plus 0. So I would say yes, this does vary directly because it passes through 0, 0. Okay, it passes through the origin. Number 2, okay, I'm typing this again into stat edit. It gave me a chart. So I'm going to type that in. -3, 1, and 3. And I have 0, 3, and 6. And this is what I'm given for my slope and my y-intercept. So I'm going to round to 2 decimal places. So my slope is 0.964, so 0.96. And my y-intercept is 2.68. Okay, the 8 rounds up to 7. So looking here, my k value is my slope, so 0.96. My y-intercept is my b, so I'm going to write that as a point, 2.68. And my equation is y equals 0.96x plus 2.68. So the question is, does this vary directly? And the answer is no, okay, because my y-intercept is 0, 2.68. Okay, remember your y-intercept has to be 0. 0, 0, it has to be going through the origin. Number 3, so on this one, we're going to solve for y, and we're going to see what our equation looks like to be able to determine if our y-intercept is 0. So I'm going to solve for y. So the first thing that I'm going to do is subtract 5x over. And I'm left with 2y equals -5x plus 0. I'm not going to put plus 0 because I don't need to have that there. Now I'm going to divide by 2 to solve for y. And I get that y equals -5/2 x. So my slope is -5/2. My y-intercept is 0. And my equation is y equals -5/2 x. So does this vary directly? So I'm looking at my y-intercept. Yes, because it passes through 0, 0. Remember, if I'm going fast at any point, you can pause it so that you can catch up. Number 4, I am again solving for y, starting off with subtracting 3x from both sides. And I get 4y equals negative 3x plus 12. The last thing that I'm doing is dividing by 4 so that I can solve for y. And I'm going to get that y equals negative 3/4 x plus 3. So my k value is going to be negative 3/4, my slope. My y-intercept right here at the end, so 0, 3. And my equation, we've already solved for it, plus 3. Again, if you're having trouble figuring out what your k and your y-intercept are, think of these equations as y equals mx plus b. Okay, our y-intercept is at the end and our slope is in front of our x. So is this a direct variation example? The answer to that is no, because my y-intercept is 0, 3. Remember, we want it to be 0, 0. Okay, flipping it over to the back, it says answer the following, and we want to look at number 5. The value of y varies directly with x. Okay, so when it varies directly with x, that's going to give us some key information. Which function represents the relationship between x and y if y is 24 and x is 18? So it tells me that the value of y varies directly with x. Which function represents the relationship between x and y? So whenever it varies directly, we can set that up as y over x. And so here it tells us that y is 24 and our x is 18. And solving this is going to help us solve for our k. So 24 over 18, you could type that in the calculator. And it gives us a decimal. I'm going to click math, enter, enter. And I get 4/3. Okay, so that is our k value. Because we know that it varies directly, we know our intercept is 0, 0. And so our equation is y equals 4/3 x. Number 6, if y varies directly with x, find the missing value. So again, it varies directly. On this one, we're going to be able to set up the full proportion. So y over x, so I'm going to look at my first point. So the y is 36 and the x is 6. The second one, I'm setting that equal to y over negative 3. Now that I have my proportion set up, I'm going to go ahead and cross multiply. So 6 times y is 6y, and 36 times 3 is negative 108. So solving for y, I'm going to divide by 6, and I get that y equals negative 18. Number 7, the number, which is y, of hamburgers that can be made varies directly with the weight of the ground beef that is used. 5 hamburgers are made using 2 pounds of ground beef. Write the function that represents the relationship to see how many pounds of beef you'll need to make 25 hamburgers. So we've started the proportion for you. We're going to have the number of hamburgers at the top, because that's our y's, and the weight at the bottom. So from the information it gave us, we could make 5 hamburgers with 2 pounds of meat. Okay, and we're going to set that equal to what we need to figure out. So we need to make 25 hamburgers, and we need to figure out how much meat that is. I put an x at the bottom because the weight of our meat is our x value. So here, that's my proportion. I'm going to go ahead and cross multiply. 2 times 25 is 50. Divide by 5. And I get that x equals 10, so that means that we would need 10 pounds of beef. To take that a step further, if I needed to, looking here, I have my y over x, so I automatically have my k. So that's my k value. So if I wanted to write an equation, it would be y equals 5/2 x, because y over x gives me my k value, just like we did on number 5. Y over x gave us 4/3, which was our k value. The last one, number 8, the amount of blood in a person's body varies directly with the body weight. A person who weighs 600 pounds has 4 quarts of blood. Which equation can be used to represent the relationship to find how many quarts of blood are in the body if you weigh 208 pounds? So we have to think about what is our y and what is our x. So we know that the amount of blood varies directly. So we're going to say y is our blood and our body weight is our x. So I'm going to say blood over weight. So now using the information, if somebody weighs 160 pounds, that goes at the bottom, and they have 4.6 quarts of blood. So before I go any further, if I were to simplify this y over x, I could solve for my k. So y over x, so 4.6 over 100. Let's see if it gives us a nice number. And it gives us 23 over 500. I'd rather just keep it as 4.6 over 100, or you can go ahead and write that. 23 over 500. So I can go ahead and write my equation, and that would be y equals 4.6 over 100x, or y equals 23 over 500x. Okay, so those are my direct variation equations, but this one is having us actually solve for something. So I want to figure out if you're 208.7 pounds, how much blood does that? Okay, that's at the top, so I'm labeling that with a y. So cross multiply. So the things that I'm circling are what I'm going to multiply together. So 160 times y equals 4.6 times 208.7. So I'm going to go ahead and multiply that. 4.6 times 208.7. And that equals 960.02. Now to solve for y, I'm going to divide by 160. And I get that y equals 6.000125. Okay, so I can round that to 6. So y equals 6. That means you'd have 6 quarts of blood in your body. Again, if you got lost anywhere in the notes, please rewind it and make sure that you go through them. And if you have any questions, please ask your teacher.